Hello, and welcome to Engineering Software as a Service. In these short intro videos for each module, I'll not only tell you what you can expect to learn in the module, but also try to give you the big picture of what to keep in mind as you're learning it. For this module, the big picture question is, why is it that we can build complex machines like airplanes and suspension bridges that have great safety records, yet virtually all software ever written seems to contain bugs? Sometimes really severe bugs that result in the loss of data or allow a successful attack by malicious adversaries. The term software engineering was coined in 1968 by MIT scientist Dr. Margaret Hamilton, the leader of the programming team for the navigation computer on the Apollo spacecraft that put the first humans on the moon. Software engineering was supposed to make software as reliable and as predictable to build as civil engineering had done for suspension bridges or aeronautical engineering had done for airplanes. But software differs from hardware in a very important way. In the plan and document processes that software engineering originally tried to adapt from civil and mechanical engineering, change is considered the enemy because hardware can't easily be changed once it's built. It's really hard to add a row of seats to an airplane or an extra lane of traffic to a bridge after they're already in use. In fact, in California in 2003, they did add extra lanes to the 40-year-old San Mateo Bridge, and it cost just as much as building the bridge in the first place. In contrast, software can continue to add features and adapt to customers' needs long after it is first deployed. This remarkable ability to change means software can have a potentially long service life. In fact, the U.S. Defense Department's contract management software might be the oldest software still in use for more than 80 years. But change also means that software is potentially always trying new things and learning from mistakes, as it tries to keep up with customers' evolving needs. Indeed, early suspension bridges and airplanes did fail because the designers were trying new techniques, and once they learned from their mistakes, those machines did become much more reliable. The malleability of software is the reason that in the early 2000s, a group of software engineers proposed a new way to develop software called agile development. Instead of considering change to be the enemy, Agile embraces the fact that software can change after it's in service, and instead asks the question, how would we redesign software development processes to take advantage of that flexibility while managing the software's complexity so that changing it later isn't a nightmare? In this module, you'll learn the differences between plan and document and agile approaches to software engineering. You'll understand how to choose the right approach for a particular project and get introduced to some of the processes and tools that Agile uses to accomplish its goals. Don't be surprised if some of those processes and tools are new to you, such as writing tests before you write code, or hoping that someday someone will refer to your software as legacy code. Our message, and the message of many students who have taken this course, is this: trust the process, embrace the opportunity to learn something new, and we believe it will dramatically improve the way you create your own software.